Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Okay, again and again, welcome to seeing me again and to seeing you again. Okay, I'm going to talk about the phenomena supporting the kinetic theory of matter. You know, we talked about matter, we talked about the kinetic theory. Now we are talking about the phenomena that supported the kinetic theory of matter. The phenomena that supported the theoretical explanation of the movement of the particles of matter. Where did they get this thing from in supporting this kinetic theory? Which laws that they used in supporting this kinetic theory? That's the kinetic theory of matter we're going to talk about. Now, first one is at the end of this lesson, you should know the phenomena that supports the kinetic theory about diffusion and how to explain solid, liquid, and gas using diffusion. Now, diffusion. The first one is diffusion. Diffusion. Diffusion is gotten from the Latin word diffundere. Diffundere means spread out. As you can see, they're spreading out. Okay? They're spreading out. That is the word diffusion. Now, in the first experimental study in modern science that came to play in diffusion was done by Thomas Graham. Thomas Graham in 1831 to 1833. This is the time he used in understanding diffusion. When they say spread out, the spread out is talking about gases. Remember, kinetic theory of matter is basically on the particles of matter. In essence, it's talking about the particles in gases, the gas molecules. That's what diffusion is talking about. The gas molecules. How do the gas molecules spread out? How do they behave? Okay? How do they diffuse? How do they surround? That is what diffusion is talking about. How they spread, how they move, okay? How the particles operate theoretically and practically. Okay? That is the word diffusion. Like I said, spread out. Which people are spreading out? The gas molecules are spreading out. I told you that I told you in the kinetic theory of matter that the state of matter do not make the movement. What makes the movement is the particles of matter. Now, what is diffusion? What is diffusion? Diffusion is a random movement of particles by which there is a net flow of matter from a region of high to low concentration. It is a random movement, random movement. They do not have destination. They move haphazardly. Okay, movement of particles by which there is a net flow of matter from a region of high to low concentration. Now, which particles of matter move randomly? I told you in gases that gases move, particles of matter, the molecules in matter move randomly. As you can see, they're moving randomly from a region of high to low concentration. Take, for example, you spray a scent in a garden, in a flower garden. Okay, now when you spray that scent, the scent will come out. Okay, that particular aroma will be massive to you. At that time, you perceive it very well. Now, when it enters into the atmosphere, the smell will reduce. The aroma will be reducing. Okay, the way that sweet smell is going to be reducing. Why? Because that first time it came out, okay, it's going to overtake the atmosphere. But at a particular point in time, it is going to be, the scent is going to be reducing. And as it's reducing, it is calling from high concentration to low concentration. It's like you just spray a perfume. Or better say you fart. Fart means you mess. Okay? When you mess, it's going to smell hard. But later, the smell is going to be reduced. In essence, the first time it came out high, in high rate of smell. Then later it's going to be what? Reduced. Now that process where this thing happens is called diffusion. Net flow of matter. That spray is a matter. When it comes out, it's a matter. So that matter ranges from high to low concentration. Why? Because of the particles. Okay? The particles made the change from high to low. In essence, now for them to move, okay, for the particles to come out, making this movement from high to low, they must have to have an energy. And it's the energy that will hit the force. Okay? It is the energy that will bring out the word force. As you can see on your screen, they are coming out from high the first time they came out. And when they enter the atmosphere, they are scattered. In essence, they being scattered means they are going their own way. And if they are going their own way, they will not have that effectiveness as of when they were together. As of when the particles were together. Now the particles were together inside the spray, inside the container of the spray. When you bring them out, the particles will move around. Now those particles are called diffused particles. Those particles that move around are called diffused particles. When they come out, the particles now spread randomly. They move anyhow they like. In essence, the smell will not be as strong as when it came out the first time. Because when it came out the first time, they were together. And now they are scattered. So in essence, that togetherness brings about the high smell, the high concentration. When they scatters, it becomes a low concentration. And they are going to use strength and energy in moving. They're going to use strength. They're going to use energy. The molecules will use energy in making this high and low concentration. It is only when the molecule scatters that it can go down to low concentration. Now, the energy and the force they use is called molecular energy and molecular force. Molecular energy and molecular force. We said movement of particles. These particles can be atoms, molecules, or ions. Remember, kinetic theory is talking about the particles of matter. So these particles is kinetic, is atoms, molecules, and the ions. So the net flow of matter. Okay, there is a flow. The gases flow. This flow of matter, the state of matter are gases. Remember, diffusion is on gases. The state of matter is gases. In essence, the movement of particles, okay, that will flow in the gaseous state of matter will bring about the high to low concentration. That's only when the high, that is only when diffusion can occur. That's only when there will be a region of high to low concentration. And the energy that they will use in this their flowing, in this their movement is called molecular energy. And the force that will come out from that molecular energy is called molecular force. Now, let's know what molecular energy and molecular force is. Molecular energy is the energy required for molecules to be in motion. Molecules to be in motion. Now, I put there kinetic. We know that kinetic energy is energy you possess in motion. And the molecular force is the force that acts upon molecules to process their motive power. In essence, to process them to process them in their work. You know, when they are in the container and you spray them, okay, when you bring them out, they will walk. They will do a walk. That walk is what will give you the aroma. That work is what will give you the scent when it's scenting. Okay? Now when they go out, they will not exhibit their motive power mechanical. In essence, kinetic has changed to mechanical energy. They will spread. When they spread, they'll go their individual ways. When they go their individual way, the scent or the smell will now become low. That is why we say it is from a high concentration to a low concentration. Now the next one is, what is concentration? Concentration is the quantity of a solute present in a given quantity of a solution. Quantity of a solute present in a given quantity of what? A solution. Now, this particular scent is a solution already. They are solutes. Okay, these molecules are solutes. Okay, they are solute inside the solution. I told you the solution cannot be complete except there is a solvent and a solute. So in essence, the liquid, the gas, remember, I told you that every gas is a liquid because of condensation. And if a gas is put in a container, it becomes a liquid. In essence, that scent, okay, that aroma becomes a liquid. When you spray it out, you see that it becomes a gas. So the solute presence are the molecules. That is what brings about the concentration. In essence, if a solute it's been dissolved in a solution, it becomes a concentration. Now the next one is how diffusion can be driven. How can we drive diffusion? How can diffusion be gotten? It is driven by a gradient in Gibbs free energy or chemical potential. Driven by a gradient in Gibbs free energy or chemical potential. Now, what is a gradient? A gradient is a change of value of quantity. Concentration, pressure, temperature, etc. Change of value of quantity. Now, when this spray comes out, first of all, the quantity, okay, the amount of spray inside. Okay, now when you spray, when you bring out the spray, I always use perfume, that spray, because it's very easy to analyze. When you spray, when that spray comes out, okay, remember there will be a change of the value of a quantity. There will be a change because it will not be the same as what you got because you brought out something. You brought them out. Okay, now when you bring them out, their values will change. First of all, they inside the container, they're hitting the walls of the container. Now when they come out, they move randomly. So their value has been changed. Now when this change happens, that is when it will change from a high to low concentration. Now they say concentration gradient. Now, when there's a change in concentration over a distance, it's called concentration gradient. This concentration, high to low, there's a distance. Okay, when I say high to means movement. To means distance. So there's a distance. When this distance is being achieved via concentration, it's called concentration gradient. Why? Because the concentration has changed the quantity of the perfume. Do you understand what I said? The concentration has changed the quantity of this perfume because of the movement of the random molecules that is being gotten in the gas. Now the next one is the Gibbs free energy. The Gibbs free energy is a quantity that is used to measure the maximum amount of work done in a thermodynamic system when the temperature and pressure are kept constant. This is just a simple explanation of the molecule's motive power. Of the molecule's motive power. In essence, when you measure the amount of work you've done, it becomes your motive power, mechanical advantage. And I told you that thermodynamic is a science that deals with work, energy, heat, and pressure, heat and temperature. So I told you that. So this particular thing is basically on the temperature. Okay, basically on the temperature and pressure. The pressure used in pressing the perfume to come out. That is the same pressure that the gas is going to come out with. In essence, your pressure used in pressing and the pressure the gas is coming out with is directly proportional. It's the same. It is the same. So that pressure is kept constant. Okay? Now the Gibbs energy is the quantity used to measure the amount of work, to measure the amount of the molecules that have taken place. Because the pressure used in pressing will be the same pressure the molecules we use in giving. If you press them small, they will come out small. If you press them high, they will come out high. Now, when you press a perfume with so much pressure, you will see that it takes time to lose the scent. To lose the what? Scent. Because that pressure you use in coming out, that is what the molecules are going to use to work. But if you press it a little bit, it's only small that will come out. That means it's going to, the smell or the scent is going to elapse quickly. So the way you press the perfume to come out determines the way the molecules are going to operate in making it high concentration to low concentration for it to be diffusion. And the next one is chemical potential. Now for you to calculate the amount of energy, the energy must be stored first of all. For you to calculate the amount of energy you have used, that energy must be stored because you cannot measure something that is moving. In essence, you cannot measure something that is what? Moving. So the energy will be stored first for you to measure it. Now it's called chemical potential because chemical energy is still potential energy. Chemical energy is a class of potential energy. They say is the rate of change of free energy in thermodynamic system with respect to the change of number of particles of the species that are added to the system. The perfume, you spray, it comes out, boom. When it comes out, there's a free energy for them. Why? Because they move around freely. Okay, they move around freely. And the number of particles changes. Because as it comes out in bulk, okay, as the perfume comes out in bulk, you see the particles going. They are spreading. In essence, as they are spreading, they are changing their position. And they changing this position causes the low concentration of that perfume that you sprayed. In essence, it causes the low concentration of diffusion. Now the next one is the law of diffusion. Law of diffusion. It depends on particles' random walk and results in the mixing of mass transport without direct bulk motion. Particles' random walk. The particles move randomly. The molecules move randomly and result in the mixing of mass transport without direct bulk motion. Now, in essence, the bulk motion is not direct. It is scattered. Like I said, when you spray this thing, the molecules come out in bulk in the gases. They come out in bulk, okay? But they don't move simultaneously. They don't move parallelly. They don't move orderly. They scatter. So in essence, it is not a direct bulk motion. Bulk, you know, is plenty. Plenty movement. It is not like that. So as they move around, as they random walk, they move anyhow. So in essence, it results in a mixing of mass transport. As they go around, they just move around, mix up with the atmosphere, and their strength of scent will reduce. I'm using the scent. The strength of their scent will reduce because they are no more together. It's like when 8 of you are together fighting, okay, you beat one person. Now, when you're scattered individually, the person might be beating all of you individually. But when you come together, the person might not beat all of you at the same time. So that's the same thing that when the gas comes out in bulk, they scatter. And when they scatter, they lose their strength. And when they lose their strength, the high concentration goes to low concentration. Now, bulk motion or bulk flow is the movement of the entire body due to pressure gradient. Like I said, the movement of the entire system, plenty, all of them coming out. Okay? They come out in bulk. But when they enter the atmosphere, they do their random walk and scatters. Now, this bulk motion is a characteristic of advention and convention. You know, when you talk about heat energy has convection. You know, it's one of the means or medium of heat transfer. Okay, one of the medium of heat transfer, and the opposite of it is advection. But in this diffusion, it's talking about fluids. This diffusion is talking about fluids. Okay, gas is a fluid. It's talking about fluids. While that one is talking about transporting heat from one medium to another. Now, advection is the transport of a substance or quantity by bulk motion of fluid. While convection is the motion of fluid driven by what? Density. Now, like I said, this bulk motion is a characteristic of advention and convention. Now, the advention is the transport of a substance or quantity by bulk motion of fluid. Now, when these people come out in bulk, it's advention. Now, when they scatter, because of their size, okay, because of their size and the volume they will occupy is convention. Remember, the molecules, the molecules do not move with the same speed. Molecules do not move with the same speed. In essence, one will have a lower mass and volume than the other. But they will come out in bulk first from the substance that been brought out from. So when they come out, because of diffusion in bulk, okay, it becomes advention. Now when they come out, the one that has more mass and occupies more volume moves faster than the one that has lower volume and lower mass and occupy lesser volume. Remember, it is the gases that does it is the gases that causes diffusion, the gas molecules that causes what? Diffusion. Like I said, when these gas molecules move and spread, okay, from bulk motion, they spread because of convention, a change will happen from a high to a low concentration. Now the next one is, how does diffusion occur? How does it occur? Okay. It occurs when the gas molecules are in continuous random motion. The molecules will eventually reach anywhere they can. These molecules, when they come out, I'm still using the perfume. Let's say you spray the perfume now in the garden, in the flower garden, like I said. When you spray it, when they come out, okay, they're in continuous random motion. That is why the scent is coming. When they come out, you see them randomly moving. The scent is coming. So, but when they face the atmosphere and they scatter, and they reach anywhere they can, individually, they are no more together when they come out. So in essence, they go in their individual ways, their separate ways. When they go their separate ways, that strength of being united together is no more there. So the strength of the scent will be no more there. Why? Because they've scattered and been their individual ways. So the scent now will be going down a little bit. As it's going down, it's getting low. From that high that they came out, that pressure that they came out from, it will be going down very low until the smell will scatter and give them a low concentration. That's how diffusion works. Now the next one is the Fick's law. The Fick's law, okay, supports diffusion. The diffusion flux is proportional to the negative of the concentration gradient. The diffusion flux is proportional to the negative of the concentration gradient. We know what concentration is. So the diffusion flux, we know what the flux is. It's proportional to the negative. Proportional to the negative of the concentration. Now, what is a flux? A flux is a vector representing the quantity and direction of transfer. So in essence, this quantity and direction is equal to the concentration. This quantity and direction is equal to the what? Concentration. Like I said, the quantity, they come out in a bulk flow. When they come out in a bulk flow, the concentration is high at that time. Now, when they scatter, the direction of their transfer, when they scatter and go anywhere they like, the concentration will become what? Low. So in essence, anyhow, the movement, the quantity and the direction affects the concentration. It affects the concentration. So if they, as they are coming out, it is a vector. Okay? It is what? A vector. A vector quantity is a quantity that has no magnitude and direction. So in essence, the direction, okay, vector quantity is anything that has magnitude and what direction. So the vector representing the quantity, okay, so the quantity of the gas molecules, quantity, they will be together. When you say quantity, that means they are together. So the quantity of the gas molecules, so that means when they are together, it becomes a high concentration. And when they transfer, the direction of transfer, direction means movement. They move anyhow they like. Now, when they make the movement anyhow they like, they change to a low concentration because of their movement randomly. Now, the next one is molecular diffusion. Molecular diffusion is the thermal motion of all fluid particles at temperature above absolute zero. Molecular diffusion is a thermal motion. Thermal means application of heat of all fluids, particles at temperature above absolute zero. So in essence, when heat is added, diffusion can still occur. When heat is added, diffusion can still occur. Now when you add heat to a substance, okay, the temperature increases. When you remove the heat, the temperature reduces. In essence, diffusion has occurred. Molecular diffusion has what? Occurred. Because when you add heat, the molecules move faster. Remember, I told you that diffusion occurs when the molecules move, when the molecules come out in bulk. So when they come out in bulk, they move. They come out faster. Now, when they are scattered, they become slower. So it changes from high to low. Now, when you add heat, thermal, okay, to a fluid, like I told fluid, I defined fluid for you. I said a fluid is any substance that deforms under shear stress, under force, under heat. Okay? And the subsets of fluid are liquid, gas, and plasma. So in essence, this diffusion is talking about gases. So when you add thermal motion, let's take for example on a gas. When you add thermal motion on a gas, when you add heat on a fluid, okay? You add heat on a fluid, molecular diffusion. When you add heat on a fluid, the molecules in the fluid will move faster. Why? Because of that heat. That heat will make them move faster. That heat will give them more kinetic energy. Remember, gas molecules have the highest kinetic energy. Gas has the highest kinetic energy. So that heat will give them more kinetic energy. In essence, their temperature will increase. Now, when you remove the heat, their temperature will reduce. In essence, adding heat will give them a high concentration. Then when you remove the heat, it will give them a low concentration. In that context, diffusion has occurred. And the name of that diffusion is called molecular diffusion. Molecular diffusion. Now, expression of diffusion. Each model of diffusion expresses diffusion flux with the use of concentration, densities, and their derivation. So each model of diffusion expresses diffusion flux. Diffusion flux means the quantity and their direction. So each model of diffusion expresses how the molecules come out in bulk and how they move with the use of concentration, either high or low, depending on their mass, which is the density, and how they came out, their derivation, from which kind of gas, which type of fluid, what type of molecule. So diffusion expresses, number one, the quantity of the gas molecules and and their direction, which is diffusion flux. The use of the concentration, is it high or low? The density, the mass of the particular particle and the volume they occupy, and the kind of gas this particular molecule came out from. That's what diffusion expresses. How do they move? Their movement will cause a region of high to low concentration based on the mass and volume they occupy. And it is tantamount to where they came out from, what type of gas they came out from. Now the next one is using diffusion to explain solid, liquid, and gas. Solid is the slowest in diffusion because the particles are held in fixed position by strong cohesive forces. Cohesive forces are forces that exist between molecules of the same atom, between atoms of the same molecule. Cohesive forces is the forces that exist between atoms of the same molecule. So the diffusion is slowest because of this particular thing. They cannot move randomly. They cannot move from high to low concentration very well because they are fixed together. Okay, their cohesive force is very strong. They have very strong cohesive force. So their atoms are tight. So they cannot diffuse. Liquid is slower because particles have less kinetic energy and are restricted and they have hazard movement due to the cohesive forces between them. Due to the cohesive forces between them. So, these liquids, okay, have hazardous movement because of the cohesive forces are not really strong as that of a solid. As that of a solid. Cohesive forces is not as strong as that of a solid. So in essence, the haphazard movement is spread, okay? The haphazard movement is open. So in essence, diffusion can really occur. Like I told you about the thermal diffusion, molecular diffusion, thermal in fluid. Okay, if you add, okay, now let's say now you add heat on a liquid, it becomes hot. Okay, when you remove the heat, you'll see that the water will be getting cold slowly. In essence, that hotness is a high concentration. Now, when you remove the heat and the water is getting cold slowly, they are going to a low concentration. In that context, the molecules are going to a low concentration. They are going to have a less kinetic energy. Remember, when the heat is added, their kinetic energy will be high. When the heat is removed, their kinetic energy will be what? Slow. So as the kinetic energy is going down of the molecules, kinetic energy of the particles is going down. That is how they are getting low. That is how you're getting a low concentration. Now for gases, gas are the fastest in diffusion because the gas particles have more kinetic energy. The rate of diffusion of gases is determined by their densities. I just explained that for you. That these gas molecules do not have the same mass and they occupy the same volume. Next, that is why they don't move with the same speed because one is bigger than one. So it is determined by their densities. It is determined by their mass. Okay, the amount by their mass and is determined by the volume they can occupy. That is how they can make their movement. Why? Because they have a random movement. They have the highest kinetic energy. They move randomly. So the next is the facts about diffusion. Facts about diffusion. It refers to the movement of fluid particles moving from an area of high to low concentration. We've talked about that. I've explained that to you, how these things occur, how the movement of fluid particles causes high to low concentration. Now, second, it refers to the movement of fluid molecules in porous solids. Now, remember, these solids are closed. It refers to the movement of fluid molecules in porous solid. Remember, for a solid to turn to a fluid, it must have to be exposed to heat. Now, the heat gained, like I told you, in melting, the heat gained is used to scatter. It's used to scatter the molecules, the particles. Now, when it scatters the particles, the particular solid will melt. And when the particular solid melts, it turns to a fluid, which means it turns to what? A liquid. Now, when this heat comes, remember evaporation takes place, which is the gases. In essence, the solid, in melting, there are three things that occur. The three states of matter is there in melting. The solid state itself, the gaseous state that removes the particles, and the liquid state that the solid state is turning into. So in essence, when this thing is done, there's the movement, diffusion is occurring. Why? Because as this evaporation is taking place, okay, it is moving from a high concentration, being strengthened, to a low concentration when it enters the atmosphere. The low concentration occurs only when gas molecules are exposed to the atmosphere. As in low concentration can occur. Okay, so when this thing happens, this particular movement, okay, from the solid changing to a liquid and gas, because melting, the solid is changing to liquid and gas at the same time in melting. So when this thing is done, the fluid molecules move, fluid, which means the gas and the liquid. That vapor that comes out is a gas. The gas and the liquid, the movement of their particles, okay, will change from high concentration to a low concentration. And that is how diffusion occurs in melting. Now, molecular diffusion occurs when collision with another is more likely than the collision with the pole walls. Yes. Okay, when the collision happens, they hit themselves. Remember, when they are in a container, they have a random movement, the molecules. So when they hit themselves, they hit the wall and come back. When they are hitting themselves, as they're hitting themselves, collision takes place. And when collision takes place, there's a breakage of evaporation. And when the evaporation comes out, okay, diffusion occurs. Take, for example, a boiling water. The molecules on the boiling water will hit themselves, collision and break. When they break, evaporation occurs. Now that evaporation becomes diffusing. Now, it is also a process of two gases mixing if stored in one container, homogeneous mixture. Homogeneous mixture, we know that when two things come together to form a single product, that's homogeneous. They form a single thing, they dissolve well and form a single homogeneous mixture. So these two gases can still be hydrogen and oxygen inside a particular container. They will mix together and form something for you. Two gases mixing if stored in one container. If you put hydrogen and oxygen, both of them will mix together and they will give you a homogeneous mixture because they mix. It is when they mix, when they react, they will form water. Now, the other one says it proceeds as a maximum rate in gases, lower rate in liquid, and the lowest rate in a solid. It's the same thing, like I said. It is a maximum rate in gases. Diffusion is faster in gases, lower in liquid, and lowest in solids. Now, the distinguishing feature of diffusion. The distinguishing feature of diffusion. The distinguishing feature of diffusion. This is the feature of diffusion. It depends on the particular random walk and results in the mixing of mass transport without requiring direct bulk motion. Simple. It depends on how the particles move. How they move depends on how diffusion will occur. If they move faster, diffusion will occur faster. If they move slower, diffusion will occur slower. So it results to this without direct without direct bulk motion. It does not depend on bulk motion, okay? Because the gases does not depend on bulk motion. When they come out, they move randomly. They scatter anyhow, and that is how diffusion occurs. Now we've come to the end of this section, but before we leave, we use our exam guide to answer a question from this particular thing we have learned to quantify the thing that you got. The distinguishing feature of diffusion, that's what I want to talk about now. They say it depends on the particular random walk and results in the mixing or mass transport without requiring direct bulk motion. Without requiring direct bulk motion. Now, in essence, it depends on how the molecules move. Now, the way they move will determine the change of a high to low concentration. It's like I want to run. As I'm running, okay, the way I run will depend, okay, will determine the hotness of my skin. Once I run fast, my skin will be hot faster. Once I run slow, my skin will be hot slower. So it depends on how these particular molecules move that will result to the diffusion state of the gas molecules, moving from a high concentration to a low concentration. It does not determine bulk motion. It does not mean that they must come out in bulk. Okay? Now, before I leave, I told you something that I'm going to tell you the phenomena that supported the kinetic theory of matter. The phenomena that supported the kinetic theory of matter are diffusion, Brownian motion, osmosis, and dialysis. I repeat, diffusion, Brownian motion, osmosis, and dialysis. What we talked about today is diffusion. The phenomena that supported the kinetic theory of matter are diffusion, osmosis, dialysis, and the Brownian motion. Thank you very much. We've come to the end of this section. But before then, we use our exam guide to quantify what we have learned. So go to 2016, question 21. Question 21. It said the spreading of scent of a flower in a garden is an example of. I told you that when scent comes out, okay, it comes out strong. The aroma comes out strong, high rate. Now when the molecules are exposed into the atmosphere, the scent becomes low. In essence, they change from high concentration to a low concentration, and that thing is called diffusion. Now let's see the first one is Brownian motion, no. Second one is diffusion. That is the answer. Thank you for participating in today's class. You can practice more questions using the exam guide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.